the kind of stuff where Neil Armstrong was the first man to swim on Earth. It's not that kind of stuff. You can catch that. It's basically saying, no, it wasn't Neil Armstrong, but it was Buzz Aldrin who was the first to walk on the moon. So that's one type of hallucination where there is a problem with the fact itself. Trust is based on credibility. Credibility is based on knowing what passes the smell test and what doesn't pass the smell test. At the foundation of all of that from a generative AI context are hallucinations. So hence my deep interest in that. We would want our AI to be not just highly accurate, not just easier to deploy, use, and drive change management. We also want it to be explainable.
Welcome, Prashant, to the AM Media House podcast Simulated Reality. I'm very excited to have this conversation with you. I know we've discussed a lot before the call itself, before setting up this interview, and there were so many interesting anecdotes and intakes that you already gave me. So I'm very excited to present them to our audience. You wanted to talk about hallucinations in Gen AI. Everybody wants to talk how they're building fantastic Gen AI, but you wanted to talk about hallucinations. So what was the thought process behind it? So let's start with that.
Let's start first with the podcast, right? And simulated reality. So if we are going to talk about simulated reality, we have to talk hallucinations and facts, right? So I'd say one of the inspirations was actually the podcast itself, Kashyap. So credit to you and Analytics India magazine for that. And having said that, yes, everybody is building the greatest Gen AI or is claiming to or wants to. So I don't think that is in any dispute at all. At the same time, one of the things, especially given that on a B2C level, this has been the quickest adopted technology slash product in human history from a tech perspective. And when you take a look at all of the excitement that has happened, there also has been a bit of a reality check going back to things, right? And that reality check has been at first when things happened, I would say roughly about 15 months ago, give or take. It's not that large language models are new to me or to H2O AI or others. We were always using it in our own products for a long time internally. But the B2C thing also meant that in addition to the excitement, there were certain things that became pretty obvious. One is this whole concept of hallucinations. So I think it's quickly, before we get into why I'm interested in hallucinations, I'm going to talk about what is a hallucination, right? So hallucination, as I define it, or others have defined it, is typically what is known as nonsensical content, a nonsensical generated response. What defines nonsense we will go into. Or it is unfaithful to the user's needs or asks or source data. That's the second thing that characterizes a hallucination. The third thing that I have come both through my own practice and research and work in the trenches is what I call confidently incorrect statements. The LLM saying something absolutely confidently, right? That it's not the kind of stuff where Neil Armstrong was the first man to swim on Earth. It's not that kind of stuff. You can catch that. It's basically saying, no, it wasn't Neil Armstrong, but it was Buzz Aldrin who was the first to walk on the moon. Right? But it does it with confidence. It may even do it with citations to the web or documents. Right? So the question is, in order for us to develop Gen AI to the greatest potential, the first thing that, as we do with any human-human relationship or the upcoming human-machine relationship, is one of trust. Trust is based on credibility. Credibility is based on knowing what passes the smell test and what doesn't pass the smell test. At the foundation of all of that from a generative AI context are hallucinations. So hence my deep interest in that. And I don't look at them always as bad, by the way. Kashyap, I know we'll talk about this later. But I think even as hallucinations are bad, I believe that there are certain instances in health and life sciences where they can actually be pretty useful.
Okay. I think, we did talk about this, and this is something that I definitely want to touch upon. And before we dive into more details on hallucinations, you specifically wanted to talk about hallucinations in pharma and healthcare or the life sciences industry, right? With that context in mind, right, how do hallucinations take a distinct form or meaning within the realm of healthcare? And how does this kind of redefine our understanding compared to other applications of AI?
So I think one of the things I would like to do, if you'll allow me, is probably just talk about some definitional terms. As you know from my previous talks and my books, I am maybe it's the linguistics communications degree in me, but I'll always like to define terms so that we have a common basis of understanding, right? So I just want to touch upon quickly the types of hallucinations that exist out there and what impact they have in a health and life sciences perspective. So I would say that if you start breaking down hallucinations into types, the first type of hallucination is what we call factuality based hallucinations. This is where you know very clearly that the generated response or the presented response, irrespective of how it is derived, but you assume there's an LLM somewhere in the mix, is verifiably untrue, right? So you know from the response when you compare to the real world or you compare to a verifiable facts that the response is untrue. So, for example, if you say who's the lead author of demystifying AI for the enterprise, in this case it's me, but it says the answer is Kashyap. Now, a quick Google search will show that it's not Kashyap, it's actually Prashant. So that's one type of hallucination where there is a problem with the fact itself. There's other type of second type of hallucination is the faithfulness based hallucination, as some others have coined it. And faithfulness based hallucination is the response may have fact based information in it. So if I ask the question saying who wrote demystifying AI for the enterprise, and the response is Prashant Natrajan shot the movie demystifying AI for the enterprise. There's a lot of things that are true about it. I am the creator. The title is true, but it is not a movie. It is actually a book. So essentially, the response is not being faithful to either the training data, or it is not being faithful during inferencing, or it is not being faithful to the user's expectations or the context. That's second type of hallucination. The third type is what I call retrieval based hallucinations, because when first LLMs came out, one of the approaches that everybody jumped on was looking at RAG and various types of RAG to see, okay, what can we do? How can we leverage embeddings to get to create a fact-based maybe solar system within the larger universe in order to control things. But what I'm seeing, speaking for myself, is that also has certain challenges which we can touch upon later if needed. But I think there's going to be the question of retrieval based hallucinations, which are going to be driven by either embedding or lexical or semantic definitions. How do these matter in health and life sciences? They matter because healthcare and life sciences contain the most diverse set of data on the planet. I always like to tell people that health and life sciences are not one industry. They're a microcosm of about 10 different, 15 different industries. One of the cancer centers I worked with essentially had a supply chain that was equal to most mid-sized department chains. You don't expect it, but you know what? Cancer drugs are very expensive, and this was a large cancer center. So when you take a look at that, while we appreciate that hospitals are primarily doing patient care, and we appreciate that the pharma companies are primarily working on devices or drugs to cure or manage disease, we should also appreciate the fact that there are revenue cycle needs, supply chain needs, talent, future of work needs, right? Community engagement. There are other things that happen in health and life sciences. There's real time data that we collect from CPAP machines, that we collect from continuous glucose monitors. So, when you take a look at the sheer breadth of data, I'll start with the fundamentals. And when you take a look at the breadth of use cases where Gen AI and AI can be applied, all these contributory factors to hallucinations can impact how AI is used, how it is accepted, and whether we are successful or not in making it real for the humans of healthcare.
Got it. Got it. Thank you so much. I think one of the things that you mentioned is basically the different types of hallucination. And I think that sets the context really well. So thank you for doing that. Right. At the same time, my second question to you is why specifically in the healthcare do you think the potential consequences of AI hallucination carry such a significant weight? Right. How does the sensitivity of healthcare industry amplify the gravity of these concerns?
Yeah, so again, I can go into a deep answer, takes area by area, domain by domain, whether it's disease or therapeutic area. It could be for example, training and certification. It could be supply chain, but we could be having a much longer conversation than 20 minutes or 30 minutes, right? That can go on for the whole weekend. So what I'll do is I'll ask us to contextualize this in the case of something that all of us will understand, the role of a patient. Now, whether you're going to your local pharmacy to pick up a drug to manage your chronic disease, or for your parents, or for your child, getting them thing, or if you're trying to take a decision or not on whether you should take the uh, latest vaccine that has come out based on certain, for example, comorbidities, or whether it comes to fundamental decisions about how we like to be treated as individuals and people, right? We in healthcare, a lot of healthcare, unlike other industries, is not about instant gratification. It's not like retail. It's not like going to Dave and Buster's. Nothing wrong with it. But my point is, healthcare happens when people are not well. We have to understand that people don't take tablets because it's fun, except hypochondriacs. Most people take it because they need to cure a disease, right? So, our goal in health and life sciences is to get people back to their normal activities of daily living as soon as possible, as effectively as possible, and while managing what I call the cost quality ratio, right? And hopefully a ratio in which they are both directly impacted. So, just from a fundamental thing of none of us would want a disease that affects us or our loved ones not to be identified. We would hate it if we didn't have a screening for a mental condition that could have saved a child something down the line. We would hate it if there were a misdiagnosis, a human error which happens. That's why we are called humans, right? A human error that happens, a hospital acquired infection or complication, or being a candidate for a trial on a cancer drug, which is going to give you 6 more years of life rather than 6 more months. We would want our AI to be not just highly accurate, not just easier to deploy, use, and drive change management. We also want it to be explainable. We expect it to be responsible. We expect it to be trustworthy. And
Empathetic.
based on all of that comes again credibility. So,
Mm.
hence, I would only say that separate from the science and the math and the policy aspects of it, the why we want our health AI to follow a different set of standards in certain use cases, especially clinical ones where there's a direct impact on the human, versus ones which may be others, right? Supply chain, for example, that's not related to care. I think that's what we would all want it to be as members of a democratic society, and as following the golden rule: do unto others what you'd like others to do unto you.
Yeah. Would empathy also, you mentioned several characteristics. Would empathy also counted? I know that AI can't be empathetic, at least until now, but is empathy also a character we are looking for?
Oh, absolutely. I recently co-wrote an article on LinkedIn called "The ACE Framework is What We Need in Health Generative AI," where A was attention, C was context, E was empathy.
Okay.
So you can argue that attention and context are both data science terms. And then
Okay.
you can ask, well, Prashant, why did you stop at A and C? Because that's a good question you asked. There is no healthcare that benefits us all without empathy. But at the same time, I would argue that our definition of empathy has to be broadened to not just patients and caregivers, which is our sacred duty, but also to extend it to providers, to physicians, to clinicians, the rate of burnout that's happening, the kind of challenges that are happening in healthcare. I believe strongly that the tide must raise all ships, and AI must serve all the humans of healthcare. That includes patients and caregivers, that includes physicians, nurses, and therapists. And dare I say, it also includes policymakers and officials who are responsible for making sure we get the biggest bang for our tax dollars.
Got it. Got it. Now coming back to the point, right? You mentioned that at the start of the conversation and before this conversation as well, that hallucinations also have a role to play in the development of Gen AI and its application. So I really want to understand, what do you mean by this exactly?
See, again, probably, and this may this may be a bit uncommon perspective, right? So maybe that's why we are talking. Um, but here is, and so I will not say that everything I'm going to tell you right now, I can immediately pull up 10 pieces of evidence for it because it's not there. I think it's still developing. And part of it developing is the idea of data fidelity, which I had introduced in Demystifying Big Data and Machine Learning for Healthcare in 2017, which is again healthcare specific AI book, right? So one of the things that jumped out over there was, how do we determine what is useful or not? And the idea, I've always spoken about this at length, Kashyap, that we should be looking at data fidelity and not data quality. And what I mean by that is, what is acceptable in one context may not be wrong or right in another context. So users determine, among other things, the quality of the response. So that got me thinking quite a bit, because I was also pretty irritated about hallucinations when the earliest LLMs completely misquoted me, misquoted my books. So I had all the emotions of an author who feels they are being disrespected by the LLM. Just kidding. But then when I saw, then one of the things that became pretty apparent was, okay, and this came out of some of the work we were doing at the Pistoia Alliance in life sciences R&D, especially when you look at early stage R&D molecules. One of the biggest challenges we have is limits on not just the computing tools and resources and algorithms, but also limits on human imagination. If you're going to try and come up with new drug candidates, you want to give rein to scientific imagination as much as possible. Now, much as Kashyap and Prashant also want to do that, we only have 24 hours in a day, out of which at least 8 hours, according to the doctors, we have to spend at sleep. You take about 1 hour for lunch, breakfast, dinner, and everything else. All of a sudden, you are at, okay, 14 hours, maybe 12 hours, right? So that's the best we can do. On the other hand, this is too precious, right? If you have a sibling or a parent or a child, any of us, and if we can get generative AI to come up with extremely diverse permutations and combinations of amino acids and protein folding use cases or molecules for early stage R&D, the only thing you're investing over there is computing time and resources, right? You're not necessarily taking away somebody's job by doing it. You're not even saying that you have to now learn Gen AI. You're literally taking AI to put it in high dimensional search spaces to do something that is very important, because we always don't know the lower dimensional manifolds where certain objects may be lying, right? If you take a look at the combinatorial things of molecules and amino acids, one of our goals is to kind of find the objects that live in lower dimensions so that we can apply the AIML that we use for other things today. But in order to get to that, one way to do it is potentially just using what we have today and using maybe more deterministic methods as the industry has done. And you will still be restricted by an upper ceiling. But instead, if we can use generative AI, including hallucinations, and not wonder to start with about what is a good hallucination or a bad hallucination, but still develop evaluation metrics, figure out how to detect it, figure out how to address it, I posit that we will be able to get a much more set of candidates that you can winnow them and you can test them through basically high throughput assays and whatnot, and quickly shorten both the R&D time and the R&D cost. Now, this is very important, Kashyap. Very, very important. Because typically the curve between cost and time to market have not always been directly proportional. They're usually inversely proportional, right? The only way you do it is you create a large trial with very specific candidates, or you go the precision medicine route and you come up with very strong genetic candidates. But in both cases, if you notice the way we do it, you're coming out with some very deterministic conditions and predictions ahead of time.
Mhm.
So for the first time in history, generative AI and hallucinations will actually give us a way to both increase the science combinations while also reducing the cost of creating candidates for early testing. And so it's a beautiful time. It's a beautiful time. There are people doing quite a bit of work with this. At the Pistoia Alliance, we have put out some good machine learning practices that also accounts for some of these things, including hallucinations. Send a link to you after the talk if you're interested to publish. So I think for us, in certain aspects of life sciences and healthcare, it is time for us to look at all hallucinations are bad. Let's both accept that. Can we? Yeah. But
Mhm.
can we also agree that some of these bad hallucinations, by the nature of hallucinations, they are bad, right? As I defined it earlier. But can we accept some of these can be useful? I think we can.
Okay. It's a very interesting take. So basically, you're saying that hallucinations in a way kind of enable the algorithms to learn by themselves, or
Maybe, maybe, but I would say the key point I'm making is it allows you to come up with new combinations of X in a high dimensional search space, which are otherwise not possible by humans or the current state of non generative AI.
okay, but then why is that a good thing? Like I'm
Why?
still
Because that's what you want, right? If you want to take a look at X combination of molecules that can lead to the next miracle drug for multiple sclerosis, right? You want those combinations to happen as much as possible, hallucinations or not. And then you figure out then what is good or what is bad and you test them out. So instead of trying out 100 options in early stage R&D, you're trying out 10,000 options and
okay.
you're doing it at not a huge added expense. Conversely, when you increase the denominator, your cost per unit is also going to reduce.
But then you're saying that at a research stage, not at a application that is
That's right.
implemented.
That's right. That's right. Again, I'm very clear that where these really work is where you don't have it's early stage R&D. So I was very specific when I said that, right?
Yeah,
So when
yeah.
you have a human involved, even human cells involved, I'll go one step further, right? You want to start putting guardrails, obviously, right?
Oh,
So the so I'm not saying that hallucinations are good, just to be very clear, in anything except this high dimensional search space of early stage molecule designs,
got it.
molecule
Got
development.
it. Yeah, I think that makes a lot of sense. I understand what you're trying to say. But when it comes to some of the applications that are deployed, right? They're not on the shelves anymore. How can healthcare professionals kind of collaborate with AI developers to ensure the reliability of the large language models, right?
Yeah, so I think, see, this is a very fundamental question. So I think there's a few things over here. It's a broad question too. One is first thing I would say, first and foremost, Kashyap, we have to accept the fact that there's a need for education. Because one of my biggest complaints about some of the hallucinations has been how confidently incorrect they are. And it plays into human psychology, where a lot of times people who are retrieving information look at the tone of the information and the confidence expressed by the information and fake citations. How many people actually go beyond the second page of Google results or even the first page of Google results to find something historically? Not many do. So I think the first thing is to understand for people at both sides. Developers get it, data scientists get it. We know that, you and I know that. But the point is, what about users? Do they understand that sometimes this can be wrong? And how do they measure it? So, education, I think, is first and foremost. That just because it looks like magic doesn't mean it's nice magic. First, it's a token generation machine. It's the next letter prediction machine. So, how do we, for understanding the nature of LLMs is important. Understanding that they are next letter token level predictors is important from a usage perspective. From a data perspective, the nature of the source data, the training data, the nature of training and inferencing all become important. That is the job of data scientists and data engineers and others, right? I think we also need to look at hallucination detection. How do we do it through formal methods? Come up with benchmarks and also look at some mitigation options. From a mitigation options, I look at it as three or four areas, maybe five, that we need to focus on. One is the data itself. What type of data are you using? Is the data itself biased, for example? But that's a simple one, right? It could also be other challenges with the data where the data is not biased, but the distribution is wrong. Because don't forget one thing, a lot of everybody, I think by now who's in the space knows the common definition that an LLM, strictly speaking, is a next token prediction machine using auto regression, right? Strict definition. But I think the key thing to many people don't realize is LLMs are optimized for completion, they are not optimized for accuracy,
Mm-hmm.
right? So getting the sentence complete is more important than making sure. So you cannot expect these LLMs to behave other than how they behave. So we have to address training, inferencing conditions, potentially using fine tuning to teach some manners. And I would also say that one of the areas, interestingly, I'm seeing where you can manage these is narrow the scope of the problem, narrow the scope of the solution space, and narrow the knowledge boundaries that you're throwing the LLM at, conversely.
Mm-hmm. And finally, to enable this, right, what are some of the guardrails that developers need to put to ensure that this there is a safe use of these technologies?
Yeah, I would say guardrails.
Is there a framework that you have?
I'm writing one now for the next book that's coming up,
Fantastic.
Generative AI for Health and Medicine, which is the next book. There is a framework, there are some guardrails. And again, I wouldn't say that now the guardrails that exist today, I'll tell you in all honesty, will change by the time the book comes out. So I'll have to probably do a quick revision, which is why I'm self publishing it this time. Because of that reason, because what we know today is what we know today. Those guardrails may change. The nature of LLMs may have become better in certain aspects where today's guardrails may not apply anymore, right? Or we may discover certain new characteristics. One of the challenges, interesting things you have been seeing with some of the other stuff that exists out there without naming them. Memorization seems to be a problem with even some of the later GPT models, GPT-4 included, where it just vomits out exact training data examples, and they've shut it down now, but you can see, right? So if that happens, then you're really wondering, right? So it may require new mitigation options tomorrow. So having said that, I would say there's a couple of things. Going back to the types of hallucinations that can exist and how do we get value out of it, what I would tell developers to do is start looking at LLM evaluation, look at hallucination hallucination mitigation, not just bias mitigation. Because you can do all the bias mitigation you want and still have poorly performing hallucinatory models. So it's one part of it. It's not the only part. So checking factuality, checking faithfulness, potentially using techniques like adversarial techniques and human in the loop are all things, right? And then from some of the conversations I've been having within folks at H2O who are really the top folks, I believe, in the space. From a RAG perspective, citation accuracy, coverage accuracy, and what I'm calling scalability accuracy are three things that we need to look at RAG. And because so many people are talking about RAG now in terms of solutions, I would say since a lot of solutions seem to be RAG based, those three things are important. If you are taking a look at other things, factuality, faithfulness, and human in the loop are all still things that need to be done from a metrics perspective, benchmarks perspective, and more importantly, active mitigation perspective, right? Not just a thumbs up, thumbs down kind of thing. That doesn't cut it in the enterprise context.
Fantastic. And my final question to you is, right, as we advance in the field of AI data science, so many things evolve very fast. You just mentioned about how your book might need a revision after you've finished writing for Gen AI. Considering this, there are a lot of stakeholders that are involved. Guardrails don't need to come specifically only from technologists. They also need to come from policymakers, and different stakeholders need to come together to ensure safe use of these AI, Gen AI, right? What is your opinion on how this impacts the innovation, and how do we strike the right balance between innovating Gen AI for healthcare use cases while also mitigating harmful impacts that it can initiate in a very fast evolving landscape? So I would like to close on this with your thoughts.
Perfect, perfect. I think you rightly pointed out in one of your sub comments there that what this takes is really a public private partnership, right? And that public private partnership not only includes institutions and organizations from government, right, and private sector companies, which have a lot of the talent they have some of the methods. Government has a need. Healthcare is a sector that is the shared commons. So it doesn't matter who we are all going to be in that system literally from the day we are born. Literally. Right? So keeping that in mind, I think it has to be a public-private partnership, but it also has to be patients first. Because yes, while the importance of productivity and efficiency are all extremely important as they are in any other business or workflow, we also cannot forget the fact that why we are all in healthcare is actually to improve the lives of patients, improve the lives of physicians and nurses. That's why we do what we do in this space. And so I think that is extremely, extremely important. I would love to call attention specifically that the not Congress, the Biden administration, various agencies and departments in the health and life sciences construct are all working actively, very actively, and I'm involved in some of them. Also, other organizations like Chai, which are pushing the needle on building these not just safeguards and guardrails, which which are not just important from a data perspective or a workflow perspective, but are important from the perspective of the fact that we are a democratic republic, right? So it's a bigger responsibility all of us have. And I'm also extremely happy to see various committees and subcommittees, for example, Veterans Health, Subcommittee on Veterans Health, focusing on this and bringing the best of the public and private sector together. There's some significant efforts happening in every federal agency that I am aware of in the health and life sciences world, which is actively looking not just at guardrails. Because anytime we talk about federal folks and regulators, people in the private sector get all scared. Like, oh my God, we can't innovate, we can't progress. No, that's not what they're saying. They're saying that in these instances, please go ahead, innovate and progress. Keep these things in mind. In these other instances, no, you have to take our permission before you decide to put a model at scale that may, for example, cut off care to someone who deserves it, right? And I think that's entirely appropriate. And like other things, it will require that public private partnership, that individual community partnership to come together in order to create the new health AI that is necessary for us all and that benefits us all.
Fantastic. On that note, thank you so much, Prashant, for coming to this discussion. I think it has been it's a lot of learning for me. I think it's a very insightful conversation. I think you put points very succinctly. You have a very clear idea of how to narrate some of your learnings and teach us with them. Thank you so much.
Thank you very much. I was very happy to be here with the Analytics India audience.